Let's review some of the concepts involved voltage and current sources. A voltage source is used to control the voltage. It means it will fix the voltage, and the current will adjust according to the Ohm's law. So what it adjusts is the current. What's the symbol? We put a circle, plus, minus, and put the E here. So this is the symbol for the voltage source. What is the typical example? Battery, laboratory power supply. For the current source, it is used to control a current. It means it provides a constant current. With the Ohm's law, because the current this time is constant, so the voltage will be adjusted according to the Ohm's law. So voltage is the variable adjust. What is the symbol? The symbol is a circle, but this time you put an arrow represent the current source. And we require a complicated transistor circuit. So there's no very simple like a battery you can visualize. It has to be constructed by a transistor complicated circuit. Next, what happens if two voltage sources are connected in parallel? Now, one important thing is if you want to connect the two voltage sources in parallel, they must be identical. This is important point. Otherwise, one of the voltage source will be a higher voltage, the other will be lower voltage, and then there will be flow of current within. So it has to be same. Now, there's one advantage of connect the two voltage source in parallel, which is like a battery. It will reduce the internal resistance. Let's look at it in detail. So we'll say a battery is modeled as an internal resistor plus a EMF. Now, if this is your first battery, and now you have another battery which connected in parallel, like this, now the same EMF. Now these two batteries connect in parallel, and then if from the outside, this is the load. So these two internal resistors, now they are connected in parallel. So the overall internal resistor will be like this. It will be half of the original, and the EMF will remain unchanged. It means if this is 5 volt, this will be 5 volt. But if the original is 1 ohm, this is 1 ohm, this will become half ohm. So what I mean is effectively you reduce the internal resistance, and it will provide more terminal voltage, and also it will supply more current. What happens if two current sources are connected in series? Again, there's one important condition, which they must be identical. Otherwise, there will create some instability in the circuit. So this is how we connect the two voltage sources and two current sources. Let's look at a simple application of KCL and KVL method. First, my apology. I have to modify this question a little bit. First, the E1 will become 14 volt. Next, we'll remove the current source. So it means we will connect this one here without the current source. So this is not a mixed source. It only has a voltage source. Now let's look at number 1. Task number 1. Label all branches current on the circuit. So here we have I1, I2, and I3. 2. Apply KCL at the junction connecting R to R3. And the current source, we don't have current source, but we know R2 and R3, and it should be R1. In this case, we can see there are 2 nodes. This is node A, this is node B. And just for make it clear, this is positive, negative. Now we apply KCL at A. So it means I1 equal to I2 plus I3. 3. Apply KVL to the left node. Okay, this is KVL. There are 2 different approaches when we apply KVL. The first approach, which physicists like to use, is to look at the rise or the fall of energy. The second approach is reverse, which is usually the electrical and electronic engineers they like to use. So I would like to follow from now on what the electrical and electronic engineers they use. So in this approach, we first select a loop. This loop can be clockwise or counterclockwise. In this case, I choose clockwise. But remember, it doesn't matter. If we choose counterclockwise, you will get the same answer. In this approach, we'll look at is how the voltage rises and falls according to a specific set of rules. These rules say we look at first the path or the loop we choose. Can you see here? When we look at this loop here, the loop enter E1, the power source, from the negative side. So we'll say this is negative E1. And then the loop here first is parallel to the current we already assigned. So this is the current and this is the loop direction. So they are parallel. So in this case, the voltage will increase. So we'll say V over 1. It means the voltage across R1. The same argument here. The path pointing down and it is parallel to the current. So in this case, it is increased. And it go back to the original, so equal to 0. Now let's express. This is minus and it is 14. One important thing is I'm not going to put any unit but keep the prefix. So 14 is good enough. Plus V1. How we calculate V1? V1 is the voltage rise in our analyze across R1. So it's I1 multiply R1. So it is I1 multiply R1. R1 is 1k ohm. Now here I only put 1k here. I don't put the unit, but keep the prefix is important. I put a bracket, so this is V1, the voltage rise across R1, plus V2. V2 is again the voltage rise across R2, which is I2 multiply R2. So I2 we know this is 2 milliamp, but we just put 2 milli. Multiply, R2 is 3K ohm, so 3K. The reason we don't keep the unit but the prefix is the prefix itself a lot of time can simplify our calculation. Say, look at this expression. We know this one here is in volt because this is the voltage. But you see here, this is milli, this is kilo. Milli means 10 to the minus 3. Kilo means 10 to the power 3. So when they combine, equal to 1. So what I mean is, you can rewrite this one as minus 14. I tidy up, I put 1K I1 equal to 6 equal to 0. So I1 or 1K I1 equal to 8. Now 8 I know is volt, but can you see here? This is I1 equal to A divided by 1K. So it is A milli. Now you can put the unit at the end, which is ampere. The M or the ampere, you put it included in the last stage. We want to calculate the voltage across R3. So let's do it. Now look at this equation. It say I1 plus equal to, or it says I1 equal to I2 plus I3. So if we know I3 and if we know R3, so we can calculate the voltage across R3. I3 equal to I1 minus I2. So it's A milliamp minus 2 milliamp and equal to 6 milliamp. So the voltage across R3, so we call the V3 is I3 R3, and it is 6 milliamp. Again, I just put the 6M. R is 1K, so I got 6 volt. The voltage across R2 must be 6 volt as well, so we can check V2, I2, R2. I2 is 2M, and this is 3K, so again 6 volt. The voltage across R2 is 6 volt, equal to the voltage across R3. So because if we modify the question, identify which element fix the voltage. This is your voltage source. Explain briefly how energy conservation appear in the KVL. So in terms of energy, this is for sure is true. Energy rises in the battery and fall in the resistors. Okay. In this part, we will review the voltage divider and also we will introduce the current divider. First, if we have a voltage source and we have two resistors, R1 and R2, you can imagine this one will divide our potential into two parts. So if we want to ask what potential across R2, we can write down the equation. So V2 is proportional to the voltage source E and the proportional constant. there are two parts. The denominator is the sum, R1 plus R2. And because you want to get the voltage across R2, so it is proportional to R2. So the same argument, the voltage across V1 is proportional to V, and the proportional constant, the denominator is R1 plus R2. And because you want to get voltage across R1, so it is proportional to R1. Let's calculate. So V2 in our case is 2K plus 4K, because proportional to R2, so this is 4K. You got 12 volt. V1, 2K plus 4K, and this is 2K, and this is 12 volt, and here you can say this is A volt, and this is 4 volt, and you can see this is A volt, 4 volt, and it divides the 12 volt into two parts. One is 4, one is 8, and which is proportional to 2K and 4K ohm resistors. Which resistor has the largest voltage drop and why? V2 in our case has the larger voltage drop because V2 is directly proportional to R2. So the R2 is higher, so the V2 also higher. 5. If a load RL is added in parallel with R2, predict the qualitatively how V2 change. It will reduce. So let's look at this again. This is 12 volt. Now this is 2K ohm, and this is 4K ohm. Now imagine now we connect another resistor, which is again 4K ohm. So these two resistors, they are connected in parallel. So effectively, you will have a circuit like this. 12 volt. This is 2K ohm. But the parallel resistor, your load modify, and it becomes 2K ohm. So it means now you will get 6 volt and you will get 6 volt. So instead of 8 volt, it will reduce it to 6 volt. Now let's look at the parallel of voltage divider, which is current divider. In a current divider, we first have a current source. This current source produces a current and is split into two resistors, R1 and R2. This time they are connected in parallel. Can you see the difference? In voltage divider, the two resistors, they are connected in series. So that's why it divides, or they divide the voltage into two parts. Here, the two resistors, they are connected in parallel. Therefore, the two resistors divide the current into two paths or two parts. So we have I1 and I2. Now let's think about qualitatively what will happen. If R is very low, it means this is approach to 0, the R2. So effectively you short the circuit. It means all the current will pass through R2. So can you see, it's sort of, the lower the resistance, the more the current will going through this path. So we have a slightly different formula. This formula say current I1 which passing through R1 is again proportional to total current I. Now the proportional constant again related to R1 and R2. Denominator R1 plus R2. But this time we want to find I1, but the numerator is what a proportional is the other R. So the numerator become R2. The same here, I2, the current passing through R2, this current is proportional to R1. So I total R1 plus R2, and this is R1. Now let's plug the number in and see what the number will get. This one is 2K plus 4K, and this is 4K, and this is 4MA, 2K plus 4K, this is 2K, this is 4MA. So the I1 is equal to 2.67 milliamp. I2 is equal to 1.33 milliamp. Now if we look at here, it makes sense. R1 is 2K, R2 4K. So R2 is higher, therefore less current will passing through R2. So this is 1.33. R1 is lower than R2, so there will be more current passing through R1. Which branch carry greater current? In this case is R1. Explain using Ohm's law. Okay, we can use Ohm's law to explain. Because R1 and R2, they are connected in parallel. So V1 must equal to V2. So I1 R1 must equal to I2 R2. So we can say because R2 is not, so I2 must be low. Because current is related to water flow in our analogy, so the higher the resistance imply less flow of water. So this is the way we can visualize or understand in terms of water flow analogy. Okay, now we can complete this table. In the voltage divider, what is control? It controls voltage because they have the same current. In current divider, it used to control current because they're parallel, so they have the same voltage. What dependent? The current is the one depend, and this is the voltage. the key equation, V equal to R1 plus R2. If we look at RV2, so make it clear. Okay, so this is V total. I2, and you can divide R1 plus R2. This is R1 I total. So the analogy we can use like a pressure drop in a series pipes. So this is the analogy, and here we can analogy this one with the flow of water speed in parallel pipes.